Hello and welcome to the biomechanical analysis of a block sprint start by Katie McKay. Within this presentation, we will analyse the block sprint start of a 20-year-old male with no experience of this performance and compare it to published literature of elite and skilled sprinters. In the sporting industry, the block sprint start is a crucial component of sprinting as it provides a foundation for athletes to maximise their speed and velocity with the use of blocks to achieve rapid acceleration. Blocks are commonly used for races such as the 100, 200 and 400 metre race, where athletes can maximise their performance with the use of blocks. The block sprint start has 4 positions such as the mark position, the set position, the push-off phase and the first step of initial acceleration. And seen below, we have some examples of elite and well-trained 100-metre sprint times. A deterministic model of acceleration was used to identify the most important biomechanical principles to achieve the goal of reaching optimal acceleration in the block sprint start. In this model, we identify the top 4 features that are most critical, both qualitative and quantitative analysis of a block sprint start. This includes hips relative to shoulders, position of hands shoulders in front of hands, horizontal velocity, and center of mass. In the set phase, positioning the hips relative to the shoulders promotes an increase in horizontal velocity for the athlete. This allows for hips to have a greater extension range of motion, allowing for the athlete to generate explosive power and force against the blocks, enhancing maximum horizontal force. In the set position, positioning the shoulders in front of the hands allows for the center of mass to be shifted forwards, which is essential for achieving a faster acceleration phase from the static position in the blocks, creating for a more effective block clearance. Center of mass is also critical for acceleration as its direction influences the body's balance and force applied to the blocks, allowing for optimal force, overcoming inertia, and promoting top speed to be reached. Acceleration is the rate at which velocity changes over time, and in sprinting this is critical for the athlete in the initial phase of the race as it allows for the development of horizontal velocity rapidly. In observing the performance of a block sprint start and analysing the data's important features, considerations in recording was taken into account. This included the camera position, lighting, background, frame rate, subject preparation, and marker placement. In recording the athlete, an iPhone was used to record slow motion stages of a block sprint start in the initial acceleration and first flight phase. This was positioned in a sagittal plane 4 meters from the athlete, allowing for a clear view of the sprinter showing their joint angles throughout the movement. Furthermore, a frame rate of 120 frames per second was used to enable slow backplay motions, allowing for detailed information to be gathered during the rapid movement. In the recording of the movement, the athlete's performance was taken in an environment where the athlete was well illuminated, removing any potential chance for sight of shadow and free from blur. The background also played a role in the recording of the movement, where there was a clear white wall used, removing any distractions and allowing for the camera to focus solely on the athlete. Prior to the beginning of the movement analysis, the athlete was informed to wear appropriate clothing suitable for the sprint block start, such as dark exercise clothing. This allowed for when the marker placement was done on the athlete's right side of the body laterally, it could easily identify the coloured markers for the critical points. The markers were placed on the radiocarpal joint of the wrist, lateral epicondyle, glenohumeral joint, hip joint, patellofemoral joint, and the talocrural joint. This ensured that precise data was collected, enabling effective evaluation of the acceleration mechanisms. The athlete was also instructed on the movements required and the rules such as on your marks, get set, and go. In recording the session, we look into the athlete's force production, body composition, and movement efficiency within the set position. In biomechanical analysis of a block sprint start, the first critical feature identified was the horizontal velocity of the athlete. This feature is critical for the block sprint start as it allows for greater hip extension range of motion. This is required to gain explosive power of force against the starting blocks, promoting the athlete to achieve maximum horizontal force. According to the journal article Biomechanics of a Sprint Start 2012, a skilled male sprinter has a horizontal velocity once leaving the blocks of 5.7 meters per second at toe off of the second post-block step. while seen in our non-skilled athlete performed the horizontal velocity of 4.33 meters per second, showing a difference of 1.37 meters per second between the skilled and non-skilled athlete when completing a block sprint start. In focusing on biomechanical changes to improve performance in the set position, correcting knee angles of both legs is critical. In the set position, aiming to achieve 90 to 110 degrees in the front knee and 115 to 130 in the rear knee is shown to allow athletes to achieve the best possible sprint starts out of the blocks. As the participating athlete shows to have a 104.4 degree for their rear leg, it is slowing down their ability to gain explosive force, power and force, decreasing their time when exiting the blocks. In the diagram, the green highlights the correct alignment where the rear leg should be to achieve maximum acceleration out of the blocks. From focusing on the athlete's degree and angle of the knee, it will enhance transfer of angular momentum, promoting maximum horizontal force. Another critical feature identified in the block start was the athlete's center of mass when in the set position. The center of mass is the point of balance in the sprinter's body between force production and block velocity. In the set position, the athlete's center of mass is adjusted by their arthropodemetric features, motor abilities, and strength, all in which can optimize overall performance. Aiming to position the center of mass as close to the start line enhances force application and the ability to produce explosive ground reaction forces. Elite athletes are evident to have their center of mass 25.7 centimeters from the start line, with well trained to be around 31.7. In this case, it can be seen that our athlete positions their center of mass 33.72 centimeters from the start line. This can be due to experience and their body configuration, such as their leg length, body composition, and strength. In correcting the participating athlete's center of mass in the set position, certain changes can be made to improve the performance according to the goal of increasing maximum acceleration. By manipulating body position by bringing the center of mass closer to the start line by approximately 8 centimeters and using weight distribution effectively will enhance this goal. In the first image, it displays the current angles and body position using the green lines, although the second image we show the effects of positioning the center of mass 8 centimeters closer to the start line with the orange outline and using the red dot as a new center of mass. By adjusting this feature, it can optimize the sprinter's performance as it impacts their force application and explosive ground reaction forces, overall impacting the effect of a strong and efficient start. In the block sprint start, maximizing horizontal velocity is influenced by the body's ability to generate force and accelerate effectively, all in which are impacted by proper alignment with the hips and rear leg. The biomechanical principle in promoting this is hips relative to shoulders. In the set position, using the feature of hips relative to shoulders allows for the sprinter to maximize their force production, allowing for a quicker and more powerful drive out of the blocks. As potential energy is stored within the leg muscles, using this technique of hips held moderately high and slightly back, the athlete can develop high force rate combined with an increase in maximal horizontal force. This increases the angle velocity and decreases the motion of inertia. In saying so, the greater range of joint extension allows for greater velocity when leaving the blocks. This also decreases the risk of injury from occurring. In the athlete's performance, it can be identified that improving their sprint starts focuses on their mobility and flexibility will be beneficial to allow correct hip alignment. This can be done by using video analysis to provide necessary feedback while allowing them to make adjustments to their positioning in the blocks. Not only will this improve their performance when exiting the blocks, but increase their range of motion, which is critical when performing the block sprint starts. Lastly, the qualitative data variable of positioning the shoulders in front of the hands is a critical feature for achieving maximum acceleration when driving out of the blocks in the set position. Not only does this critical feature shift the center of mass forward to the start line, but allows for a faster acceleration from the static position. In the set position is seen to be a key factor in the block performance. Although it does not have correlation to achieve the best times overall, its effectiveness in the sprint start is important. Positioning the athlete's shoulders in front of the hands reduces horizontal distance from the start line and moment arm, enabling powerful extension. Correct shoulder alignment results in a smooth transition from the set position to dynamic movement, allowing for a forward level momentum when pushing against the block pedals. This critical feature enables the sprinter to effectively transfer energy from the body to the track, enhancing forward propulsion while maintaining optimal balance during the initial phase of the sprint race. The image we can see the athlete positioning the shoulders over the hands is well utilized. The athlete shows a positive slight angle from the radiocarpal joint through to the glenohumeral joint, thus enhancing the center of mass and the ability to maximize their acceleration when leaving the blocks. Although the overall positioning of the body alignment with the hips through to the shoulders could be adjusted. By straightening the back, it allows for a strong positioning of the glenohumeral joint to the hip joint, promoting triple extension to be met. This allows for maximum speed and velocity to be achieved, creating the athlete to have a rapid acceleration. Seen in the diagram from the biomechanics of the track and field sprint starts, a narrative review, it displays the correct positioning required when exiting the blocks. Thank you for listening.